Welcome back to All This Math. This is Professor Parker, and today we're going to do some geometry. And I also want to give a shout out before we get started. I want to give a shout out to my little cousin Kennedy down in Georgia, who reached out to me and made a request for me to do this video. All right. Shout out to her for reaching out to get the help when the help was available. All right. So what are we working with here? Now, whenever you see a problem like this, I want you to take some time and just focus in and just look at the problem. Look at what you're dealing with. I see a circle. I see these two lines right here. These are called tangents. These are called tangents. Why are they called tangents? They're called tangents because they touch the circle at exactly one point. I know it don't look like it, but it's supposed to look like that. This line segment right here from point E to point F, this touches this circle in exactly one point. Therefore, by definition, this is a tangent. Also up here, this line touches, or is supposed to, if my drawing was more perfect, but it's not, forgive me, right? This line segment from point G to point F is also a tangent, all right? Not a secant, not a secant. Secants go through the circle. Secants go through the circle. Tangents touch the circle at one point. So secants, that's the difference between a secant and a tangent. A tangent touches the circle at exactly one point. So before we do math, we gotta do some reading comprehension if we're dealing with a word problem first, right? We gotta know some vocabulary, right? If there are a lot of terms that are involved, especially with geometry. Geometry has a lot of vocabulary. So we need to know what a tangent is. We need to know what a secant is. We need to know a lot of things, right? This is a circle, of course. I see arcs. Arcs are basically, if you imagine this circle was a pizza, right? A whole pizza. Arcs are the pizza crust, the edge, right? So this would be arc EG from point E to point G, right? Arc EG. And then what would I call the other arc? That's interesting. It doesn't really have a name. There would need to be another point identified on this circle for this other arc to have a name. Yeah, but at any rate, this arc right here, we're going to call this arc EG. And we're going to call it that because we don't know any information about it. We know that this arc from point E to point G on the other side of the circle is represented by 37x plus 3. We know that, right? Now, let me back up. Let me back up because I kind of just went in and just started talking a whole lot. First off, what are we trying to do? We're trying to find out x. And what is x? X is this value inside here, right here, where you have 37x plus 3. So that lets us know we're going to create an equation. We got to create an equation. All right, so let me keep looking at this. Let me think about what I know and what I can figure out. I know this angle is 45. Okay. I know that the arc measurement on this side of the circle from point E to point G is equal to 37x plus 3. I know that I don't know the arc measurement of this side of the circle from point E to point G, but I do know something. There's a theory. See, in geometry, there's so many theories. And you got to either have the theorems written down in your notebook or in your textbook and have access to it, or you got to have them memorized. Either way. There's a theory that says that if I'm dealing with a tangent-tangent situation, the angle that's formed by those two tangents must be supplementary with the measure of the arc. The measure of the arc that angle is closest to. So this will be the arc that this angle is closest to in the circle. It's got to be supplementary with it. Now, what does supplementary mean? That's another vocabulary term that we must know. Supplementary means that the two measurements add up to 180. The two measurements add up to 180. So what that tells me is that I can figure out what this arc measure is. If this angle and this arc measure are supplementary, that means that I could take 180 and subtract 45, and whatever that equals will be the measurement of this arc. So 180 minus 45, 180 minus 40 is 140, minus another 5 is 135. So that means that this arc is 135 degrees. Now, how do I know that? I know that because there's a theory in geometry, a trusted and proven theorem that says the angle formed by two tangents to a circle is supplementary with the arc that's closest to that angle. So this arc is closer, this arc is further away. This arc is closer, this arc is further away. And remember, arcs are like pizza crust on a large pizza or medium pizza, whatever size pizza, it don't matter. All right, so now we know some information. So now what do? Now we can set up an equation because we also know some other information about when we have a tangent-tangent situation. When we have a tangent-tangent situation, right, we know that the angle formed is equal to, or the measure of the measure of the angle formed is equal to 1/2 times big arc minus little arc. Big arc minus little arc. You ever played a game or heard of the game, big bank take little bank? When I use this formula, I always think of that. I always think of big bank take little bank because basically it's big arc take little arc. All right. So this over here is my big arc. This is my big arc, right? And this is my little arc. Now, let me pause for a minute because what if I didn't know that this was my little arc? What if I didn't know? What if I was thinking, well, how do I know that this ain't the little arc? This is how you know. Because the total degree measurements of all arcs in any circle must add up to 360. They must add up to 360. So that means that if this arc is only 135, this other arc is going to be the difference between 360 and 135. And 360 and 135, let me think of that. 360 take away 100, that's 260. 260 take away 30 is 230. 230 take away 5 is 225. So that means that this arc must be 225 degrees. And you know what? I ain't even realized this. That's another way we could figure out what x is. See, that's the beauty of math. The beauty of math is there's not going to be just one way to get to the answer. There's going to be multiple ways to get to the answer, right? But let's stick to this for a minute. Right? But I just thought, as I was going through that, I just realized there's another way that we can come up with the answer. We can come up with a way to solve for x. All right? But anyway, that's how I know that this is the little arc. This is the little arc because that's only 135. If this is only 135, the other side got to be, what do we say, 225. Yeah. The other part of the circle got to be 225. So, of course, 225 is more than 135. So 135 is the little arc. Now, I plug in anything I know. I know the measure of this angle is given to us. That's 45. Equal sign. Then I got 1/2. Then I know the big arc is 37x plus 3. Right? Minus the little arc, which is 135. Right? Now I got to do some algebra. First thing I'm going to do, I'm going to combine the like terms inside. Actually, no. First thing I'm going to do, I'm going to get rid of this 1/2. I'm going to multiply by 2 on both sides. That's how we get rid of the 1/2, right? The opposite of multiplying something by 1/2 is multiplying something by 2. Because really, multiplying something by 1/2 is really just dividing by 2. That's what it is. It's dividing by 2. Some textbooks will show the formula like this. They'll say big arc minus little arc all over 2, right? Because multiplying by 1/2 and dividing by 2 are the exact same thing. They're the exact same thing. All right? So now, if I multiply by 2 on the right side, I got to multiply by 2 on the left side. So 2 times 45 is going to be 90. This 2 and this 2 cancel out. So now I'm left with, on the right side, 37x. And I need to combine. I can combine this 3 and this negative 135. 3 minus 135 is negative 132. Right? Now, I want to isolate 37x. So I need to get rid of negative 132. The way I get rid of negative 132 is I do the opposite operation. The opposite of subtracting 132 is adding 132. So I'm going to do plus 132 right here. And I'm going to do plus 132 right here. These cancel out. What's 90 plus 132? Let me see. 132 plus 100 will be 232. And let me back off. Let me take 10 off of that. So that's going to be 222. So 222 equals 37x. Now I want to isolate x. So I need to eliminate this 37. This 37's got to go. So I'm going to do the opposite operation. Again, because in algebra, we do opposite operations to get rid of things. So the opposite of multiplying by 37 is dividing by 37. And I'm going to divide by 37 on the right And I'm going to divide by 37 on the left. 222 divided by 37. I know this because I did the problem already. 222 divided by 37 is 6. 6 times 30 is 180. 6 times 7 is 42. 180 plus 42 is 222. So x equals 6. But I'm a strong advocate of always checking your work, because you don't want to go through all this effort, do all this work, get an answer, and just think that the answer's right. You want to know for sure that the answer's right. So how can I prove that this answer is right? There's a couple ways I could do it. We already said that all the arcs in any circle have to add up to 360. We already said that. So I know one arc is 135. And if this x equals to 6 actually, then that means that 37 times 6 plus 3 should equal 225. So let's see. Let's see if 37 times 6 plus 3 actually equals 225. So what's 37 times 6? We knew 222 divided by 37 was 6. So that means 37 times 6 has to be 222. And everything works out nice and neat. So therefore, x does equal 6. All right. So just a little bit of work with the tangent-tangent theorem. Tangent-tangent theorem. How to find the measures of angles using the tangent-tangent theorem. This is part of circle geometry. All right. Part of circle geometry. So if you haven't already, please like the video, share the video with somebody, subscribe to the page if you haven't subscribed already. Tell your friends, subscribe to the page also. All right. Okay. And yeah, that's about it. That's about it. Tangent-tangent theorem. Okay. And always remember, there's all this math all around you. Peace out.